Good evening, everyone. My name is Kaziani Ahmed. My N number is N1546057, and tonight I'll be doing homework number 3 for digital signal processing 6113 per Professor Chen. I'll be solving problem that I've already solved it. What I'm going to do is I'm going to walk through each step and explain why certain pole and zero diagram response corresponds to certain impulse response given to us. So the first diagram, number 1, we have two poles. They're on the axis, and they're on each side. One on the negative side, one on the positive side. So it's going to decay, but the impulse response is going to have oscillation on each side, be it positive and negative, which is why it corresponds to impulse response 6. We can say that for sure. Now let's move on to the second one, which is the pole and zero diagram number 2. So what we have here, we just have 1, 0, and it's on the axis. It's right there. It's on towards the right hand side. So we can kind of write it mathematically. We can say that h of z is c over z minus 0.76. And just to make sure we're zooming here, we can't know for sure, but what we were given on the homework sheet, we can assume that, hey, it's somewhere around 0.7, 0.8, so let's say 0.7. So we can write the impulse response as 0.7 to the power of n u of n. So it's monotonically decaying, and the impulse response which corresponds to is 1. And the hints were also given to us by professor, so if you just look through that, and then we can decide it perfectly. Now let's look at the third one rather, the pole and zero diagram, which is number 3. So for this, we have 3 poles, 2 on top of another, and 1 on the axis, and they're very close to the unit circle. So we can kind of also write it mathematically. The hints were also given to us by the professor. What we have here is ZQ divided by, because there are 3 zeros, which also, it's right here, I should rewrite it, 3 zeros. So z cubed divided by z minus alpha times z minus 0.9. Now the first two terms, since one is on the top and one is on the minus, these two terms will become c1 r of n sine of n omega t plus 5. And now this is simple. This would be c of 2, which is the second term, 0.n, it's right there, 0.n, and the whole thing will be multiplied with u of n. Now this is going to be monotonic decay, but it's going to slowly move from the oscillation from the center slowly, which is kind of like that. It's going to have decaying, but as it's decaying, it's going to repeat slowly, and it's going to move away from the center. So we can say for sure it's going to be impulse response 7. Let's go to the second one, the fourth one actually. The fourth one, we have 2 poles, one on the top and one on the bottom, and they're very close. They're kind of close to the center of the origin, which means it's going to have less frequency, but it's going to decay with less frequency. We can say that it's going to be impulse response 5. Now for the pole and zero diagram number 5, we have 2 poles that are closer than this one, and they're closer to the origin than pole and diagram number 4. So that since they're very close, the origin means it's going to be very less oscillation, and it's going to decay very quickly. So you can say that it's impulse response number 2. The pole and zero diagram number 5, it's very similar to number 4. Very similar. It just has smaller number for its poles. They look very similar. It's hard to tell from the pictures, but on the given problem sheet, they just have a lesser pole number than number 4. So we can say they're close to the unit circle, so it's decaying, but with oscillation, which means it's going to be impulse response number 8. Now for pole and zero diagram 7, we have, so for this, we have 2 poles. This is 0. There are 2 zeros, and this also has 2 zeros, by the way. So there are 2 poles, but they're pretty large and they're very steep in a way. So the frequency will be high. It's going to decay but since it's very close to the unit circle and very steep, it's gonna have very large high frequency. So we can say it's impulse response number 3. Now for the last one, not for the last one, for the last one actually, for Poland 0 diagram 8, I didn't draw it, but from the picture given to us, we can say that there are 2 poles and they're both outside the unit circle. And if they're outside the unit circle, it's unstable. So what we know when it's unstable, if it's unstable, this impulse response will diverge, meaning as it goes on, it's going to get bigger oscillation. So it's going to diverge. So that means it's going to be impulse response 4. So that's the only one that has a diverge impulse response, meaning it's unstable, indicating to that. So that would be all. Thank you.